Hi guys, so today I was supposed to teach you guys 1.5. I'm titling this Solving Quadratic Equations Using Square Roots. So we've been solving quadratic equations before in 1.3 and 1.4, but the method that we were using there was factoring. Whenever we're trying to solve an equation, what we're trying to get is an answer with x equals and then whatever number. So that's what our goal here is. We're just using a different method to get to that goal. As we're solving equations in this chapter, we're actually going to learn 4 different ways to do it, because sometimes one method is easier than the others to use, so we just want to be able to differentiate when we should use each method. The first method that you guys learned was through factoring. This is the second one. We're going to be using square roots to solve our quadratic equations. Remember, our quadratic equations are anything with an x squared in it. Okay, so before we actually get into solving though, I want to make sure we know how to simplify square roots as much as possible. So I want to start off with some review. Simplifying square roots, just in case people forgot. So let's do the square root of 98. So remember, what you wanted to do was to break up the number inside the radical as much as possible. So I could start dividing by 2. I want to figure out what times what is 98. Well, if I divide by 2, I end up with 49. So 2 times 49 is the same as 98. From here, I know that I can break up my radicals so that I have radical 2 times the radical 49. And then you should see that the radical of 49, or square root of 49, is just 7. Because 7 squared is 49. So really we have square root of 2 times 7. This is starting to look much nicer, not as big of numbers to deal with. So the only thing is we need to write this mathematically nicely. So usually the whole number goes in front of the radical. So our answer would be written as 7 radical 2. And then we're done, because the 2 doesn't break up anymore. Let's try another one. 108. So let's pretend you didn't have a calculator and you couldn't divide by numbers like 49, because who knows. The fastest way is to actually use squared numbers like 1, 4, 9, 16, 25, 36, 49, and so on. That way you know you can take out the numbers from the square roots. So because I don't have a calculator for whatever reason, I'm just going to start with smaller numbers. So I'm going to start with 4, because I think 108 is divisible by 4. It looks like it. So I'm going to try it out. 108 divided by 4 gives me 27. Okay, well, smaller numbers already. I can break up the 27 pretty easily, because I know it's divisible by 9, which is a perfect square. And 27 is the same as 9 times 3. So I've broken it down pretty far already. I've got 2 square numbers, so this is the same as square root of 4 times the square root of 9 times the square root of 3. Well, the square root of 4 is 2, the square root of 9 is 3, and then the square root of 3 doesn't simplify anymore. The numbers on the outside, they always get multiplied. So 2 times 3 is 6, square root 3. That's my final answer. Okay, let's step it up here. Let's do square root of 10 times the square root of 15. Well, here, since I have them as separate radicals, I would want them to be a single square root, written as a single square root, so I could try to multiply the 2 numbers together, square root of 150. But then once I get to this point, I still have to simplify it, so I actually need to break up this 150 again. So this step right here was actually kind of useless. If I'm going to have to break it up again, I'm going to get 10 times 15 back, which is what I started with. So instead, what I'm going to do is break up the 10 and the 15. Because 10 is 2 times 5, and 15 is 5 times 3. Well, inside now, do you see how you have a 5 and a 5? That's actually 25. So really, we have the square root of 2 times 5 times the square root of 3. So I just simplified that step right there, because we have doubles of the 5s. That's actually 5 squared, so the square root of 5 squared is 5. From here, the 2 and the 3, you can't simplify those anymore. So I'm going to end up with 5 square root 6 if I multiply the 2 and the 3 together. And that's fully simplified. Okay, Let's go on to dividing. So if we have a square root to simplify that looks like this, 15 over 4. Kind of like how we could break up with our multiplying, we can also break up our radicals with dividing. So this would be the same as root 15 over root 4. Well, the square root of 4 is just 2. And then the 15, we can break it down into 5 times 3, but there's nothing to pull out from there, from the radical, so this is fully simplified. Square root of 15 over 2. If we had, say, the square root of 5 over 8, same thing, I could split up the top and the bottom. But here, the 5 doesn't simplify anymore, but the 8 does simplify more. So I'm actually going to break up the 8 into 4 times 2. And I know the square root of 4 is 2, so I end up with 2 root 2 on the bottom, with a square root of 5 on top. This part, I don't know if you remember, but this is a rule where you're not allowed to have radicals on the bottom. Mathematically, it doesn't look nice, so that's considered a no-no. We want to be able to get rid of radicals on the bottom. The way to do that is multiply by whatever radical you have on the bottom. Some people learned it as multiply by the whole entire thing on the bottom, to both the top and the bottom, but it's actually it'll still be correct if you do it that way, but it's actually more steps to reduce at the end, and you work with bigger numbers, and nobody wants that. So I'm just going to multiply by whatever radical that I had and that I want to get rid of. When I multiply it, though, I want to do it to both the top and the bottom, because technically, right here, since this is the same number on both top and bottom, I'm actually multiplying my original fraction by 1, because square root of 2 divided by square root of 2 is actually just 1. So it doesn't change the value of what I started with. If I just multiplied by root 2, that I can't do that, because why am I suddenly multiplying by a random number? That changes the value of what I started with, so I'm not allowed to do that. But if I multiply to both the top and the bottom, then I'm allowed, because it's like multiplying by 1, and whenever you multiply by 1, you always get the same thing. So from here, I'm going to start with the bottom and simplify the bottom first. I have 2 times the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is just 2. So I have this 2 that started out from front, and then the square root of 2 times the square root of 2 is square root of 4, which becomes 2. On top, I have the square root of 5 times the square root of 2, which is the square root of 10, and it doesn't break down anymore. So simplifying this down, I have square root of 10 over 4. That's the proper way to write our original fraction without radicals on the bottom. Okay, let me show you another example with radicals on the bottom. This time it's a little different. We have 4 divided by 5 minus the square root of 2. Okay, if we applied the same process, this part, don't write down. I just want to show you something. If we applied the same process and just multiplied the top and bottom by the square root of 2, because that's what was in the radical, here, this 5 minus the square root of 2, it's actually connected together. They have to stay together. So it's kind of like having parentheses around it. When you're multiplying all of that stuff by something else, you'd have to distribute. So this is the same as square root of 2 times, 5 minus square root of 2. And then if you distribute it, 5 times the square root of 2 is 5 square root of 2. Square root of 2 times square root of 2 is 2. But whatever I get from that, I still have a radical there. That's not what I wanted. Instead of multiplying by just what was in the radical, if you have these two things being connected together by something, you need to multiply by something that looks like this. 5 plus the square root of 2. So notice that the sign in the middle has changed. This number right here, this 5 plus square root of 2, is called the conjugate. There's a special name for this term when you just flip the middle sign. Because when you multiply by the conjugate, our goal is to cancel out any of the radicals on the bottom. And by canceling out, I mean when you FOIL out your two terms, the radicals will add up to 0. That's our goal. So here, let me rewrite this so it looks nicer. We have 4 over 5 minus square root 2 times 5 plus square root 2 on top and 5 plus square root 2 on bottom. And then I'm going to FOIL out the bottom and distribute the top. So first terms is 5 times 5. I get 25. Outside terms, 5 times square root of 2 is 5 square root 2. Inside terms, negative square root of 2 times 5 is minus 5 root 2. And last terms, negative square root 2 times square root 2 is minus 2. Okay, so there's all the stuff on the bottom. Notice how we have a 5 square root 2 minus 5 square root 2. They add up to 0. So now on the bottom, we're just left with 25 minus 2, which is 23. Now we have no more radicals on the bottom. That was our goal. So let's deal with the top now. We have this 4 times 5 plus root 2. We just got to distribute that. So 4 times 5 is 20. 4 times square root of 2 is 4 square root 2. Let me rewrite this. And I'm done. That's my final answer. Okay. I think we are ready to actually solve things now. So let me start off with solving. We're going to start with 3x squared equals 150. Okay, remember when we're solving, we're trying to get x by itself on one side. So our first step, which would be to get rid of that 3. We want to divide both sides by 3. So I get x squared equals 50, because 150 divided by 3 is 50. Next, we're almost at x by itself. We just have that power of 2 there, an exponent of 2. So the opposite of squaring something is square rooting something. So I'm going to square root both sides. Alright, here. This is where it gets a little weird. Because we're taking the square root of x squared, we end up with x. On the other side, though, when we take the square root of 50, we actually need to put a plus or minus there. And I'll tell you why. So when you take the square root of something, we're trying to find out what squared will give you 50. Well, if you have the square root of 50 and you square it, you will get 50. But if you take a negative square root of 50, you'll also get 50, because a negative times a negative is a positive. So this negative square root 50 also works. That's why we have to list both the positive and the negative version. So anytime you take the square root of both sides in an equation, you're going to need to put that plus or minus there. Lastly, we want to make sure this square root of 50 is simplified all the way. So breaking it down, we get 25 times 2. So that becomes plus or minus 5 square root 2. Here we actually have two answers in our equations. We have a positive 5 square root of 2 and a negative 5 square root of 2. Just keep that in mind. This always comes out as two answers. Okay, let's do another one. This time I want 3 times x minus 2 squared equals 40. Alright, so first step, we want to make sure we get rid of anything that's the farthest away from the x. So that would be the 3. Divide both sides by 3. I'm left with x minus 2 squared equals 40. At this point, I know a lot of people want to add the 2 to both sides. You actually can't do that yet because we have this square here. That 2 is connected with the x here with the parentheses, so you don't want to do that until after you get rid of the parentheses. So, opposite of squaring is square root, so square root both sides. That leaves us with just the x minus 2 on that left side. And then since we took the square root of both sides, we want to make sure we have that plus or minus there again. Oops, totally forgot to divide by 3. 40 divided by 3. Okay. Alright, so we have x minus 2 equals plus or minus square root of 40 over 3. Well, remember that 40 over 3 is actually the square root of 40 over the square root of 3. and we're not allowed to have radicals on the bottom. So let's simplify this down first. So to get rid of that radical 3 on the bottom, we want to multiply the top and the bottom by radical 3. That leaves me with, oh, there's a plus or minus in front, 3 on the bottom, because square root of 3 times square root of 3 is 3. On top, we have square root of 40 times the square root of 3. But remember, I don't actually want to multiply that together because I'm just going to have to break it down again. So I'm actually going to break apart my 40 and turn it into 4 times 10, which is 5 times 2. And then I have that 3 at the end. So really, that's plus or minus. Well, only the 4 is a perfect square, so that becomes 2, and then 5 times 2 times 3 is 30, all over 3. Okay, let me come back here then. So, we figured out x minus 2 is equal to plus or minus 2 square root 30 over 3. Alright, so we've simplified our radical, but we don't have x by itself yet. This is when we want to add 2 to the other side. So adding 2 to the other side, you can just take this fraction that you had before and add 2 at the end, but they don't actually combine together since you don't have common denominators here, because this is a fraction. But in math, though, we like to write things nicely, you know. Our special way of writing things is usually to keep the plus or minus sign in the middle of whatever you have. So the number will come first and then plus or minus whatever. So that's how we usually write it, but that is our final answer. Keep in mind, this is 2 separate numbers. If you were to find this as a decimal in the calculator, we have 2 plus 2 times the square root of 30 over 3. I think that comes out to like 5 point something. And then the other way, if you did 2 minus 2 times the square root of 30 divided by 3, that's a separate number. It's another decimal. I think you get negative 1.65 something something. Huge decimals. Just wanted to remind you, when you have decimals that don't repeat, we had special words for these types of numbers. Remember, there was real, rational, irrational, all of those. If you have decimals that don't repeat, that go on forever, these are irrational numbers. So in case you were wondering what these were, a lot of times your radicals will be your irrational numbers. Okay, so we got solving here. We got 2 different types. I'm going to do one more. We're going to do 5x squared plus 33 equals 3. Alright, so same process. We want to get x by itself on one side. So I'm going to subtract 33 on both sides first. That leaves me with negative 30 on the right. And then I'm going to divide by 5. So that x squared equals negative 6. Alright, we want to get rid of the square, so square root both sides. You get x equals, and then what the heck is this? Square root of negative 6. Pretty sure in the past you guys learned this as no solution or something like that, because you weren't allowed to take the square root of a negative number. Well, remember when we were talking about the different types of numbers? We had real numbers, and all of the numbers that we were talking about were real. Well, the opposite of that was imaginary numbers. This is when they occur. When you take the square root of a negative number, you end up with imaginary numbers. So I'm going to write this part on the side over here. Imaginary numbers. We use this cool little I to stand for imaginary numbers. You know, I for imaginary. I actually stands for the square root of negative 1. So this part's very important because this is what we use all the time. So we never actually write the square root of negative 1. We always use I. Because if I were to solve this out, the square root of negative 6, I would break up, first of all, there would be a plus or minus since I took the square root of both sides. I would break up that square root of negative 6 into the square root of negative 1 times the square root of 6. So here I would rewrite the square root of negative 1 into I for the imaginary number, and then we have that root 6. So this is my final answer. X is equal to plus or minus I square root 6. Okay. One thing I want to point out, these are like fun facts for our imaginary numbers. If you square I, that means we would have the square root of -1 times the square root of -1, or the square root of -1 squared, which gives us just -1. So if you square i's, you come out with nice real numbers. So that part's kind of cool. If we cube I, if you cube I, and we wanted to simplify this down, you can actually rewrite this as I squared times I, because technically you have 3 i's still. I squared times I is I cubed. Well, earlier we said I squared was the same as -1. So really, I cubed is the same as -1 times I, which is usually written as -I, because we never write -1I. It's not a thing. So -I. One more. I to the 4th power. I'm going to rewrite this again using what we had before. Well, I to the 4th can be rewritten as I squared times I squared. And earlier we said I squared was -1. So I to the 4th is actually -1 times -1. And that just equals +1. So I to the 4th is actually the same as +1. Kind of cool. Fun facts. Alright. That's all I wanted you guys to get to for this section. So on Tuesday, when I'm not there, this video should help you do the work on Tuesday, and then also the homework for tonight. So again, if you have any questions, need any extra help, come find me on Friday, come find me on Wednesday. Have a good long weekend. Bye.